the size of the file should be say minimized. In what sense we want that? So probably like the way the example that I gave that day may be helpful in some sense, but do we think that every time we would be getting size to be smaller? Would be one important question. Correct. Now, if I really see rather how exactly one can really contribute into what we can call it as getting a size of file to be very small. Probably the C code can be directly replaced by assembly, and that's what generally is referred as inline assembly programming. Right? Inline assembly programming. So this could be possible. Like if I write mixture of C and assembly together. Mixture in the sense in C code, you yourself would be writing a code which will contribute into say a C code. OK, inside a C code, there would be like GCC supports you making use of ASM keyword. In bracket, you can write your assembly code. Correct. So like how exactly it looks like. So let me show you that part. OK. Yes. So see if I can get something. Yes. So let me share the screen with you. Probably. Yeah. Can you see this code? Can you see this screen now?
Yes, sir.
So like what happens is GCC permits you to make use of inline assembly. Correct. So for example, if you go here, you may be able to see the code like from what are the resources that are available. Correct. Let me take this for example. So that you will be seeing how exactly this can be used in the code. Like suppose your code would be like suppose this is a C function that you wrote. Acquire lock, and in that acquire lock you are writing this ASM keyword, and inside that code you are writing assembly instructions. So these are the assembly instructions that we have written probably in double quotes. So this will minimize completely load of the system. Now to introduce that part or to show you that how exactly this tiny part or tiny representation of assembly or usage of assembly along with the code will help us out to minimize size of the cell. So let me show you this. So say for example, Sys2 .c. So I will write first a C code. Correct. So hash include stdio.h. Printf. This is just an example to show we can get a small size executable. This is one statement that I added say there, and then I'm using this function which you generally love to make use of. I hope you must have used this function multiple number of times. So let me say I have used these three files. Save. Yes, Control X2. So I am taking Davis03 asm.asm. Here I am writing section.data mhgdb Now section dot text global main push mhg call puts add esp comma 4. Okay, then move ex comma I think 1, move ex comma 0. Okay, so I don't want this put s. Say for example, I want to make use of move ex comma 4. I'm using write system call. Ebx comma 1 ecx comma mhg move edx comma len int 0x18. So this is interrupt that I am using. Okay, so this is my printf actually the way that I use there. So I'm not using any function call. I'm directly using system calls. So int 0x18. And so let me declare len equ $-mhg. So nasm dash felf 32 asm. Okay, we'll create plane first. Okay, then gcc dash m32 23 dash 03 asm dot o dash o my asm executable. Now gcc 2303.c. So we are creating now .o file. Okay, dash m32. Now if you see the files that we got are these. So this was my assembly code and C code written. This was object code for ASM. This was object code for the C code. Now let me create an executable. Dash O my C exe. Now see the sizes of respective code. This is 704, whereas this required 1544, nearly double, correct? Then this required 496. This is my assembler is exe, and this required 15584. Even if I suppose strip my ASM exe, and if I strip my CEXE, so size would be even smaller. Like now you may say, how many bytes we are saving here? 64 minus select 64 minus 28. Correct. So nearly 36 bytes are saved with your executable. Now you may say for 36 bytes, why do we require to do this? Okay, but ultimately if I see when I execute that my dot slash my CEXE, and then I'm displaying my ASMEXE. Both the codes are giving me same output. Only because I used 10 there, so it is showing me that next line, this prompt. In this case, I haven't used slash n there. That's why it added that there only. But to do the same thing, even it is exiting from the code. Correct. So if I try to debug, say GDB, okay, let me create that executable along with dash G dash dwarf. I assume I created using dash G dash no dash G dash dwarf Correct. Then control R nasm dash G dash F dwarf control R GCC. Yes. Dash G dash F dwarf. So if I write ls dash ltr, now sizes would be bigger. Like C code is nearly 180 and this is 162. Nearly, like if one can see here, 2000 bytes difference can be seen with respect to file. So if I execute that code, suppose dot slash my.exe. Sorry, my.cexe. Yeah. So if I say breakpoint main run, now you can see what it is doing. And it says process exited normally, correct? So if I again say step, it already came out of the code. Now let me execute that my.smexe. So it said exited normally here. Na? Please note this. Now let us say breakpoint main run. Now ni. This printed the text. This is just an example to show how we can get small size executable. Interrupt got executed. This also is showing you exited normally. Same thing, the way that it showed earlier with respect to C code. Similar message, only process ID changed. 21045, process 21045. In this case, it was 21055. It is only the process ID is different. Rest of the things are same. Now, when we say this, ultimately, if we are going to achieve the same thing, then why to use those lines instead? I could have written these lines so as to get my number of bytes to be lesser, because it is completely headache for an like loader, rather when it executes the code in memory to call a function, because there is always a involvement of stack every time. So like for example, if I show you, sorry, gdb dot slash my cexe. So if I say breakpoint main, okay, run. Now you will see address is changing. Now I am using next instruction. So see how many instructions are getting executed for this only. Now it is going to that printf statement. So these addresses starting from this place, when you set that ed, correct? F1, F5, F8, FB, FC, FE, FF 6000005. Now it is here. Now, like when it executes the printf, if I write ni, now you can see that address is 20e. Let me write ni. So it is executing that printf. So it executed that printf till this time. So when I use step, for example, now let me use to show you, let me use step. In a single line, it got executed this printf when I executed it in a stepwise manner. But when I executed it as an instruction point of view, ni, next instruction, I can see that it wasted this much amount of time rather to execute those lines. Now you may say here it only took a small fraction of second rather to execute printf, but actually this printf call was replaced by same thing, the code that we wrote there in your assembly code by writing that system call int0x80. Correct, and this would be advantageous in some sense, and every code that you write would be definitely converted to something like this only. When we say machine language, ultimately every code gets translated to assembly only. So even you see, for example, .NET framework, there is an assembler involved with .NET framework also. Correct. Now, if one you search about .NET assembler, you definitely will get it. IL assembler, that's what it calls as. IL assembler, which creates CLI file. Correct. And that CLI is common language infrastructure. So every .NET code that you write, with assumption, I am assuming that you might have heard about .NET framework, most popular framework on Windows platform. So you write ASP.NET code, you write C#.NET code, VB.NET code, whatever the code that you write. Ultimately, all different languages, the code would be converted to something called a CLI, common language infrastructure. Or you can even refer it as CLR, common language runtime. Because your code would be converted into that assembly in CLI form. Now, when I say that thing for with respect to .NET framework, similar thing can definitely be seen here. So everything would be boiling down to machine code only. Because when we started learning about computers, we said computers can only understand machine language. But what is machine language? So machine language is binary for you. But we saw binaries itself is hex. Like hex would be understood here on that platform. Because if I ask you write your name in binary, so what will you have to do? You have to convert each of the characters. Say for example, if I take say a particular name, say for example, Bashir. Bashir Hussain Ibrahim. Correct. So if I ask him to write his name in binary form, what is supposed to do? He is supposed to take ASCII character of ASCII value of each character that is available in his complete name. Bashir, Bashir, then Husssain. So for each character, he will take ASCII value. He will convert that ASCII value to decimal, the decimal to hex, or decimal to dialect binary, and then he would be able to write that. But do you think it would be very good to write that name into binary? No. Even writing in hex would not be comfortable. That's why we have a language for communication, which is either your mother tongue or whatever the language, like English, Marathi, Hindi, or even say other languages. Say Persian. Now, when we do talk about these languages are only front side that can be understood. Internally, meaning of those statements may be different. Now, suppose if I start talking in my own mother tongue, everybody may not be able to understand what exactly I am trying to talk. Okay, those who are familiar with Marathi may be able to understand what exactly I am trying to speak. But then at the end, we have understood even like sometimes language is not important, actions would be important. Emotions would be important. But this is good with respect to say that in real life, but computers cannot work with emotions. Though people are really working hard, researchers are really working hard to get the scenario like this. So if there's a camera associated with my laptop or a desktop or a mobile, even a front camera, it will see how my face reaction is. Depending upon it, the color combinations would be changing. So that it will communicate. Now you are angry, calm down, calm down. You are happy, be like that only. So if I can get those messages somehow, it would be helpful. Then you may say you may have to make use of IoT and communicate the things. But to even achieve that communication between two devices, system needs to have something written in what we call as machine language. So always, because you will not be able to see every time, or you will not be able to write code every time in optimized manner. Correct? Optimized manner. It would be really difficult to get through what exactly we wanted to achieve. So even like when I was talking about how exactly you can control the assignments, of assignment variable for a file or for a program when you are trying to create a ELF executable for it. So let me show you that part. Say for example, if I write, say, let me give name as tiny.c. Let me write the code. So I'm introducing you how you can get say the smaller size. So I'm simply writing this code int main. Say I'm saying void return 42. Is this a valid code, by the way? Is this a valid code? Can you hear me? Amol?
Yes, sir.
Okay, is this a valid code? Valid C code? Probably yes. Until
Yeah,
you
yes,
compile.
sir.
Yeah, until we compile this, we may not be able to comment about this. So let me try compiling this. So let me include this. Include all warnings. W all. My program name. Tiny.c. So if I see the size, what is the size? 16464. Let me use word count. Dash C. Word count characters in a.out file. 16464. Correct. Now if I try writing this as M32, I may get different size. Correct. So let me execute this code. Will I be able to get what exactly happened there? Nothing is returned, though we have said return 42. Nothing is printed. How do I get it printed there? Let me write like this: dot slash a dot out semicolon echo $1, which returns, sorry, dollar question mark, which returns the value. Now we saw that the size was even like whatever the either of way. Let me take this 32-bit only. So my the code size was 15556. So can I create again a slighter small version? So you generally do what? Strip a dot out. Now you compute this 13764. Same thing I can achieve by writing this. Correct. So okay, let me remove this so that it would be easy for you to understand. So let me write this. So I will create executable as my exe without strip. Okay, what is the size? So let us say wc-c my exe without strip. Correct. 15556. So let me copy this. My exe without strip test. I will check now ls-ltr. Do they have the same size? Right now, yes, because I copied it. So let me strip this, strip test. Now size has become smaller. Now let me do this. Let me apply this command to generate exe, like a.out executable. Now if I use this dash s, I don't require external stripping. It automatically will be creating that stripped file. If I remove that s, it will give me 15556 as the file size. You can check. Correct. So right now one can see if I strip it without externally stripping, if I create my stripped code this way by writing dash s, it will give me good decrease the size. So I have this size now, 13764. Now remember that I'm having this copy there so as to show you that we can get smaller. Can we still minimize this size? Now see what is the byte difference that you see here? So okay, let me open SQL AS select 15556 minus 13764. So 1792 is the difference. So we could save 1792 bytes, nearly 1 KB, not 1 KB. Is it 1024? Yeah, 1 KB, more than 1 KB rather. 2 KB would be 2048 bytes. So let me try to again minimize this code. Can I further minimize this? So instead of dash s now, I will include some more thing here. Or rather, okay, let me keep that dash s as well. Let me write optimize this code at third level. Okay, and I'm going to get a dot out only. Note that same size is there, so we'll compare this one, then this one, and now the one that would be getting now new a dot out. Let us check. Could we see some change? I used O3. It is same. Right? Now if you see what exactly it did, it is returning us 42. That's what we saw when we executed that dot slash a dot out. Yeah, it was returning me 42. If can I write the same code in assembly? Let me write tiny asm.asm. I have to return 42. So section.text global main. Now we know that if a value is to be returned, then it is to be stored with EX and simply write rate. Simply write rate. Let us assemble this code. nasm-f elf32 tiny asm.asm gcc-m32 tiny asm.o. Now let me take it my asm tiny exe. Now let us see the size. It is 15380 because we haven't stripped. Right? I could have used here dash s. 13656. See the difference. 13764. You got 13656. And if I execute this dot slash my asm tiny exe, in the same way I will write echo dollar question mark. It shows me that it is returning 42. Same if I write wc-c my asm tiny, it will show me 13656. Correct. That means what? Now if I try to compare here, I took 13764. Now let me write 13656. Nearly 1900 bits. Sorry, bytes. This is too much. Achieving the same goal by writing assembly code. This will definitely help you out. This will definitely help you out. Now, okay, let me think of again. Can I work more? Probably to let me try one more time to get my code done. Let me write this. So Emacs my another try asm.asm. So section dot text global main. So I will write move ex comma 1 move ebx comma 42. So return 0 आप बोलते हो ना, when you write return 0 actually it is similar to something like exit 0. So I'm writing return 42, same thing. ex1 means exit system call with return value to be 42. Now while I'm trying to compare this, I'm forcing that system to avoid using standard library. Okay, so let us try assembling this. Nasm dash APLF 32. My another try ASM GCC dash WAL dash S. I will use the same thing. Now I am specifically saying no standard library, no stdlib, and my another asm.o. What it says? Sorry, I haven't used minus M32 dash M32. Yeah. So what it says? Warning, cannot find, because when you write no stdlib, ultimately main cannot be understood by it. So then I have to definitely replace that main by that underscore start. So let me try doing this. I will write like this. Fine. Let me try again one more time. NASM and GCC. Now if I try seeing this, now see the size of the a dot out. Your as ASM tiny was having 13656. Now even I am getting smaller version of it. So if I try rather executing this dot slash a dot, sorry, controller dot slash a dot out, it is returning me same output 42. And moreover, it is showing me this size to be 12780. So our earlier size was 15556. This was the size, correct? So we brought it to 13764. We brought it to 13656. Now we are getting it as 12780. 12780. Now see the size difference. 20, nearly 3 KB. Nearly 3 KB. So if I assume that a page size is 8 KB as an operating system perspective, when you talk about paging in operating system. So my earlier size was 15556. So let me write. So select 15556 divided by 1024. How many KBs it is taking? So 15 KB is the size actually required by it. Means like 8 KB का एक होगा. So nearly 2 pages would be required to load this code. Now if I write this instead of this 15556, if I write 12780, this required 12 pages. Rather 2 pages. Same 8 KB का अगर page size है, if a page size is 8 KB, so considering size of my code to be 15556 and 1 KB to be 1024, so 15 KB would be required. And for a page, there is always 8 KB size. Every page has 8 KB size. So if it is 8 KB, then ultimately it is nearly 2 pages. Same thing is here. But if you see through compaction, I definitely can get or utilize this remaining 6. 3 probably I am not sure about whether I will be able to get it or not. Correct. Now, okay. So if it is the case, can I even get something similar to this to achieve the same similar code. So let me try. I'm again trying. Huh? My one another try. Section dot text global main. Okay, let us take underscore start. We'll try to remove that part. Start. Now I'm using XOR EX comma EX, increment EX, move EBX comma 42 INT 0x80. Let me see the size. Okay, I'm achieving the same thing by writing the code differently. So my one another ASM. Dash M32 my one another ASM dot O. Okay, so one thing, let me my another try. Na? We'll give that file name here, some name dash O. My another try. Okay, and here I will give dash O my one other. Now in both the cases, size is same 12780. So though I tried achieving that instead of writing move ex comma 1 because if I see the translation done at this level, so dash L p dot lst my another try dash L q dot lst. So let us check list p dot lst. See number of bytes taken 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Correct? And same thing if I try to check with Q. See 1, 2, 3, A5 plus 5, 10 plus 2. 2 more bytes are there rather in the code. At binary level, I can see exactly what is added. But because of my linker altogether, when I link it, at that time, few things are getting added. That's why this size becomes the same. Now, when we assemble this, sorry, linked this, we have used this dash S2. Dash S2. So this would be really, this is kind of a big achievement for us rather to see, yes, we would be definitely getting size of file to be smaller. Correct. Though you may not see a difference here because both these files are created using a linker called LD. And linker is adding its own code there to call both of them to be executables. But I showed you in byte level whatever p.lst and q.lst that we had, we can see there is a difference of number of bytes there. Okay, now here I am talking about dash. Say yes, dash S dash M32. I'm trying with this. Even I used underscore start. Why not try this one too? Let us see if it works with my machine. Emacs. One more another dot asm. So section dot text global underscore start underscore start colon move BL comma 42 XOR EX comma EX increment EX INT 0x80. Let me try this. So nasm dash F, there is a file format again called bin. So let us see whether can we get this a dot out. One more another dot ASM. Fine. Now I am making that as executable writing chmod by providing permission. This is a Linux command. Now let me execute this semicolon echo 42. Sorry, echo dollar question mark, not. Okay, it is giving me error for dollar question mark. Probably okay, let it be. But we can see 127. So if I try to see ls-ltr, correct? When I executed this, it is showing me some command not found thing in my a.out line 1, but it is showing me some output. Okay, so let me add some more thing in my assembly code. So as to avoid it probably. Let me see if I can use file size EQU dollar minus. Yeah, okay, still. Dash F bin dot O. One more another. Okay, then echo dollar question mark. Yes. Now if I try to see rather count WC dash C a dot out. Total number of bytes are only 9. Now this is giving me good opportunity rather to really search this code. But again, problem is like I'm not sure whether is it really giving me what I was expecting. So it is showing something as 127 and it is saying that in dot slash a dot out line 1 there is something missing in my code. So probably let me try one more thing. So if I can get this section dot text, probably let me remove this. Let me try. Okay, till okay, good. Okay, let me even make one another change. Move byte. Okay, to take that value into BL. Right, and then underscore start. Okay, so let me even provide its start address. org 0x08048 what was that 000 I think, yeah. Line number 3, yeah, so it is You have to change that mode. Yes. 127. Now, in terms of number of bits, rather, it dragged down to 9, which was bit, we are a bit comfortable with respect to making use of that. So maybe I may have to add some more things rather to get even smaller. Now considering like this should have worked if my machine could have not been 64-bit machine. That's the reason why the backward compatibility issues are, I can see with respect to that bin format that I'm using here. Correct? The bin format that I'm using here. It is probably creating an issue rather to execute this. Otherwise, it used to show this 42. But OK, let it be. But at least we could see how much we can save. So if I remove this dot slash a dot out rm more another dot asm. We definitely can see the changes here. This is good achievement by us rather to drag file size from 15556 to 13764 to 13656 to 12780. Correct? Good achievement. So like while writing the code, we have to always take care of this fact. And like while you are implementing any language, note here what I said, while you are implementing any language processor, you have to make sure that your user can use any abrupt thing, but you have to always provide facilities to him or her so that they can optimize their code through the commands, set of commands. So here, when we said that we are, where is GCC? We wrote somewhere. Yeah, so we wrote here, say dash O. Now, if I write dash O, say 1, say for example. I tried optimizing it at that level of optimization. This optimization level, there are 1, 2, 3, 1, 2, 3 as optimization level. So I can see that it is giving me same thing, which is a stripped version. So probably I may not be able to go beyond this, below to this, to reach to the smaller size. But definitely the kind of difference that I could see was nearly 1900 bytes. And that is good achievement from our perspective. Let us not talk about that bin part because bin probably is not working on my machine. You may try that and see whether if you can get it, but you will not because most of the laptops that you have and the support that you have, probably that there is a mismatch with respect to that bin form and the current libraries that I do have. That may be the reason. Correct, but leave apart that, one can definitely see that this kind of thing is there. So you should provide that optimization factor every time when you are permitting user to make use of say your assembler. Make use of your assembler. Correct? Okay, let me switch on the power supply since my power may go off. Yes. Correct. So work on this. Even try this kind of code on your laptop. I'm sharing these all .c file and .asm files for you. Okay, so that you can check it out and work with it. to really see rm star.o ltr. So I have to start from tiny.c and then include these 3 files. Okay, for your reference. So that you can try this and see whether can you even try and get maybe smaller than what the size was expected to be.